Hi, welcome to this lesson on 2D and 3D trigonometry part 1. Let's have a look at question 3. We're given a circle with a diameter DC, a center O, and the radius R. We're given that AC is equal to R, AE is equal to 2 times DE, and angle DOE is equal to theta. We want to show that cos of theta equals a quarter. So let's think in terms of a problem-solving strategy how we can go about this. Now I see theta here. Now when I think of cos theta, I'm trying to think everything in trigonometry that I know that could possibly have a cos theta. Well, when I deal with any trigonometric ratio, I try to look for a right angle triangle, because then I can do adjacent over hypotenuse for cos. However, we don't have any right angles that we know of. Okay? So I don't think we can use that. But what else has a cos theta? So what are the big things in trigonometry? There's an area rule, but that has sine of an angle. There is the sine rule, but that only deals with sines again. And then there's the cosine rule. The cosine rule has a cos in it. So that maybe might be a strategy that we could use. Okay, so let's go ahead and put all the given information on the diagram. So DOE is theta, that's already there. So we've used that. We know that O is the center. So this is a radius length R. So OE, OD is also a radius length R. OC is also a radius length R. And we were told that AC, this length here, is also R. So from this point C to A. So we've used that. AE is twice DE. So the length here, AE, is twice the length of this length here. Okay, so that also might be important to use. Okay, so let's try and figure out how we can do this. Now, first of all, angles on a straight line tells us that this angle must be 180 degrees minus theta. So I'm going to look at triangle AOE because there's a lot of information going in there. So I'm going to sketch that triangle out here. Okay, so from A to O, that's 2 radius lengths, so that's 2R. From O to E, that's 1 radius length R, and I have an angle included here, 180 degrees minus theta. Okay, so I could work out the length of AE if I wanted to using the cosine rule. And then, what about this triangle here? So let's write this out. Yeah, in triangle EOD, because there's also a lot of information in this one here. So let's sketch that out. We have this theta here. And we know these are 2 radius lengths, R and R. So I could work out the length ED here. So that's going to be useful because we were given a relationship between AE and DE. So let's go ahead and work out those 2 lengths and then compare them using this equation. Okay, so in triangle AOE, what do we have? So using the cosine rule, I know that AE squared, this side squared, is equal to these 2 sides squared, so R squared plus 2R squared minus 2 times the product of those 2 sides times cos of the angle between them. Okay, so let's go ahead and simplify that. So R squared is just R squared, 2R all squared, that becomes 4R squared because you square the 2 and square the R. This product here is 2 times 2 is 4, R times R is R squared, cos of 180 degrees minus theta. However, if we do reduction formulae, okay, 180 degrees minus theta is going to be here in the second quadrant where only sine is positive. So that's going to become negative cos theta, because you're reducing off the horizontal, so the ratio stays the same. R squared plus 4R squared is 5R squared. Minus minus becomes plus 4 times r squared cos theta. Okay, so that's the expression for AE all squared. In triangle EOD, we have ED squared equals these two sides squared and add, so r squared plus r squared minus 2 times the product of those two sides times cos of the angle in between them. Okay, so let's clean that up. R squared plus r squared, that's 2r squared, minus 2 times r, which is minus 2r squared times cos theta. Okay, now lastly, let's use this piece of information that we haven't used. If AE equals twice DE, now because I have these expressions in terms of squares, it makes sense to square both sides here. So this implies that AE squared is equal to, now 2 times DE squared, that's going to be 4 times DE squared. Okay, but what is AE squared? That's 5r squared plus 4r squared cos theta. And that must equal 4 times DE squared, but DE squared is this expression here. So 4 times that entire expression. Okay, cleaning that up, we have 5r squared plus 4r squared cos theta equals, expanding that out, we have 8r squared minus 8r squared cos theta. Okay, so remember the goal is to isolate cos theta. Okay, so what I'm going to do is I'm going to take over this negative 8r squared to the left-hand side. So that's going to give me positive 12r squared cos theta. And then subtract 5r squared from both sides, it's going to give me 3r squared. So therefore, if I divide both sides by 12r squared to get rid of this coefficient in the front here, it's going to be 3r squared divided by 12r squared. Okay, radius is a non-zero length here, so I can divide them out. And I have 3 over 12, which reduces to 1 over 4. Okay, so we've successfully proven that cos theta can be simplified to 1/4, given all this information in this diagram. Alright, so that's how we would do this type of problem. I'll see you in the next one.